And to the insert. Today is September 4th. I hope you all had a good holiday. Wednesday. So we were playing with a graph. Okay, and so what we were doing before, what we did before. Okay. You learn how to plot a graph in Excel. Learned about the regression equation. I call it RE. You learned about the determination coefficient R squared. R squared. Okay, the closer. R squared is to 1. Is to 1, comma. The closer your regression equation fits, the more, not the closer, the more your regression equation fits the data points you plotted. Okay, remember R squared. R squared can have a value anywhere between 0 and 1. Okay? For R squared equal to 0, if R squared is equal to 0.
Professor, I can't see your screen.
Oh, thank you. Thank you for reminding me. There you go. Now we have it. And there you go. Okay, what we did before, you learned about how to plot a graph in Excel. You learned about the regression equation, which is, I have to write it down here, which is a mathematical model for your data, for data points. You learn about the determination coefficient R squared. The closer R squared is to 1, the more your regression equations fit the data points you plotted. R squared can have a value anywhere between 0 and 1. If R squared is equal to 0, this means that the regression equation has no correlation whatsoever with the regression equation found. Okay. I also mentioned that R squared, however, keep in mind, that R squared is not the ultimate measure of the correlation between the regression equation and the data points. Okay? CL, confidence level, okay? Confidence level is instead, okay? And I mentioned that before, right? That the CL is a function of R squared and N. N is the number of data points. And so, so let's distinguish between the data points. I like to distinguish between the data points, the regression equation, okay? It's very convenient. It is very convenient in real life. Find a mathematical model of of the data of the data you get in real life. Okay, very convenient and help us a lot. Design equipments and figure out what would be, for instance, the lifetime of a given device that you have invented. Okay, and keep in mind the following: data points that you get in your experiments is what I call real life. Whereas regression equation is nothing but the mathematical model of your real life experiment. And physics is all about building mathematical models of real life. Okay? That's what physics is all about. Not just for physics, but engineering as well. We always try to build mathematical models of the real life. That's what physics is all about. Why is that? Because we want to have the ability to predict how nature behaves. How, not just how nature behaves, but how your device, the device that you invented, right? You invented behaves. And the regression equation is just one of those predictive tools. Okay? Remember, physics is about predicting what's going to happen in the future. Okay? Just like we have those predictions that the scientists are making about global warming. Okay? They have mathematical models, they have fit their mathematical model with a regression equation, and they can see where global warming is going just by looking at their regression equation. Okay? And throughout this course, we will be using, like I said before, right? Let's see, like I said before, the equation for CL is very involved slash complex. For this reason, I'm providing you with a table that will allow you to determine the CL of a given regression equation with respect to the data points you collect in your experiments. Okay. And hopefully you already got that, right? Let's go back there to my my canvas to my canvas page. Set it. So there is a table there in my canvas page. Okay, here you go. Lecture and lab notes, confidence level. Okay, I'm gonna download that. I want you to download that as well. Okay, and let's play a little bit with this table. And I want you to follow with me so you understand how we use this table. Okay, remember that I told you that confidence level is a function of n and r squared. Yeah. There you go. Confidence level is a function of n and r squared. And we do have n here. And here indeed, all those numbers that you see right in here are values, are different values for r squared. We call that the critical values of r squared. We call it critical values of r squared for a good reason, okay? So here you go. We have n here. We have r squared here. And then in this line, in this horizontal line, we have the values of CL, the confidence level. We are not going to be using this here, this column and this line. We are not going to be using those two. Concentrate.
Professor,
Yeah.
sorry. Where was this under? Is it under modules? I can't find it.
You cannot find it? So let's go back to, okay, so here go, initial page, right? Yeah, click on the initial page. You should be able to see my syllabus, my Wiley Plus, the Wiley Plus Access lecture and lab notes. Okay, should be at the top here. You know that's in Portuguese. You know, I shouldn't figure out how to put that in English, but should be the very top link on the left side. Okay, and if you click here this link, you should get to this page. Did you get it?
Yeah,
Okay,
thank you.
and then you download the confidence level. Okay.
Okay, thank you.
Okay. So so here you go. 2024. Like I said before, the equation for CL is very involved slash complex. For this reason, I won't provide you with this equation. For this reason, I will not provide you with the analytical equation, but just a table that you will be using throughout the semester. Which will allow you to determine the cell for a given regression equation and R square values and R square value with respect to the data points you collect in your experiment, okay? And now we're going to do some sample exercises on how to use this table. We'll do some sample exercises using this table. Okay? I'm going to copy and paste what I have here. Here you go. Suppose you performed an experiment. You collected 6 data points and found an R square of 0.983715. What is the confidence level of your regression equation? Okay. So let's take a look at that. I have to have my table next to those values that I provided you. right in here. And here's my, okay, so here you go. This is a simple example. It's not a real life example because you rarely will see a situation like that, but at least it will allow you to understand how to use this table, okay? Okay, so let's go 6 data points. 6 data points is right in here in this row, okay? Right in here in this row. And now what else do we have to do? You have to look for the R square in the body of this table, right? That's the body of this table. And like I said, those are what we call the critical values of R square. We call it the critical values of R square for a reason, okay? And here you go. R square is 983715. Let's look for 983715. Notice that R square from left to the right increases, right? You see that? Start at 0.65, go to 0.84, 0.94, 0.98, 0.99, and so on, right? At the far left of this table, you have the number 0. At the far right of this table, you have the number 1, right? And let's look for 983715. 983715 happens to be this very number here. I don't know, 5. Remember, I told you this is not a real life data point? Because why is that it's not a real life exercise? It's not a real life exercise because the R squared that I found in my experiment matches exactly the critical value of R squared in this table. Okay? In real, okay? But again, we're doing that just for as an exercise for you to understand how we use this table, okay? Note here we go. That the R square above, that the R square above together with N coincides with the critical value of R square. Okay? In real life, this hardly happens. Hardly happens. Throughout all my years teaching that, I found that only one group of students got an R square that was very close to this critical value. And believe me, I have corrected thousands of those reports, okay? So most likely you are not gonna get an R square that will coincide with the critical value in this table, okay? But proceeding, right? Proceeding. So at this R square value, at this N, at these N and R square values, we find that the CL is, okay, so here you go, N equal to 6, CL equal to 1 minus 10 to minus 4. Okay, so you go along the horizontal line for N, find where the R square lies, and then move upwards in the table to find your CL. Okay. Okay, so 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 23, this one here that I want, let me put aside. Okay, oops. Using the table provided. Okay, CL, we find that the CL is 1 minus 10 to minus 4. which is equal to okay, 1 minus 0.0001, right? 1, 2, 3, 4, which by the way is equal to 0.9999. Okay? Which by the way is equal to 99.99%. That's the confidence level of your mathematical model. Okay, that's the that's the confidence level of your mathematical model. The higher the confidence level of your mathematical model, the better its predictability power. Predictability power. Okay. And the higher your predictability power and the higher your predictability power, the more money you can make with your product, right? Okay. With the product that you're selling in the market, with the product you're selling in the market. You're selling in the market. You know? And that's what separates, a multi-billion dollar corporation from a startup, from a multi-million dollar startup, from a multi-million dollar startup. Okay? Multi-billion dollar corporation works at CL levels, at levels that are far closer to one than your multi-million dollar startup. Okay? Boeing, for instance, Boeing can sell an aircraft that is capable of transporting 200 passengers or more, right? 200 passengers or more. Whereas a startup, a multi-million dollar startup does not work at this CL level that would allow it to market an airplane capable of carrying that many passengers. See the difference? Many passengers. That would be the practical. That would be the practical applications of CL. That would be one of the practical applications of CL. Okay. But only, let's say, 4 passengers, right? Just like those small Cessnas that we have out there, like the small single engine Cessna airplanes, practical applications of CL. Okay? So that was an example of CL. Okay. And let's go back to our here, to our graph that we plot before, right? Let's take a look. What would be the CL of this graph? Remember, I made up this data just for illustration purposes, okay? But throughout the semester, you will work with actual real life data points, okay? You can see that the data points are not 100% aligned up with the regression equation. This line, this straight line that you see right here, dotted straight line, is is a representation of your regression equation. That's the equation of your dotted line here. That's the mathematical equation of your dotted line. Okay, let's take a look now. Now, let us do a more realistic example. Okay, consider, let's example 1, right? Here you go. Example 2, suppose you perform an experiment, right? Collected 6 data points and found an R square equal to 0.9978. What is the CL of your regression equation, right? That's the regression equation right here. Going back to our data, to our table of CL, n equal to 6 is right in here, okay? And now let's see where 0.9978 fits, right? Here in this table. We have 0.65. We should go further down to the right. We have 0.84. We shouldn't get 0.99. We have 0.94, 0.98, and then we're starting to get closer and closer to our R square. 0.99484. It's not 0.99484, it's 0.9978. So your R square in this specific case lies between those 2 points, okay? Like I said, this is a more real life type of example that you're gonna see out there. It would be very unlikely for you to have an R square value that is going to be exactly equal to the critical values of your R square in this table. But you can see that's anywhere between those 2 values, okay? 9978 is less than this value, but it's more than this value here. So the confidence level of your data points is somewhere between those 2 values that you see right here. Okay? Solution. In this case, the R square does not coincide with the critical value in our table. Okay? Instead, it lies anywhere between 2 critical values. In this case, 0.99484 0.9984 and 0.998367. Let's see, 99484, right? 484. The lower R square corresponds to a TL of 1 minus 10 to minus 5, whereas the higher R square corresponds to TL five. Let's see, Noemi is coming. CL of 10 to minus 6, right? 10 to minus 6. Consequently, your actual TL lies somewhere between these two CL values, okay? I usually call that lower bound, right? And upper bound, i.e., a lower bound of and an upper bound of upper bound, upper bound. Okay. So that's the type of problem, that's the type of R square you're going to end up seeing during the experiments, so-called, our so-called experiments. Okay, so I'm gonna give you like the step by step, right? The step by step. Okay. Okay. Okay, so it's 9:26 right now. So that I want to cover about that on CL. Okay, that's what I want to cover about the CL. Now you have everything. Now you have everything you need to find the CL of your data points. Huh? Of your data points. Okay. How many students we have? We have 23 students. Okay, and now I can blow it up like that. And I'm going to take attendance, not just attendance. Now I want to, now I want to assign you to groups, to different lab groups. Okay. And by the way, let's go back here and see the syllabus, right? We just had a holiday. I hope everybody enjoyed your Labor Day holiday. And we are here on the 4th of September, finish CL, and then lab group assignment. Okay. So I'm gonna give you the opportunity. I want to give you the opportunity. I want to give you the opportunity to choose your group, your lab, the members, right? The members of your lab group. If you know the other student, if you know any student in this class and would like to have a group with them, you can let me know. Otherwise, if you do not know anyone, which is common because this is an online course, right? I will assign you randomly to a group. Okay? And I'll do that from my roster. You go. Let's see, I'm gonna get this one here. I'm going to transfer this one right in here. Audrey Lou Agnew, are you there? I don't see Audrey here. What about Audrey Aguilar? Hello, Audrey, are you there? I can see your name here. Let's see. Let's see chat. Okay, okay, I'm gonna put a star here on Audrey's name. And the next one is Matthew James Aguirre. Aguirre.
Right here, Professor. Good morning.
Good morning. Do you know any students in the class that you'd like to make a group with?
Honestly, I do not. I'm from LA Trade Tech, so you could go ahead and just assign me with any group.
Okay. Okay, so I'm gonna put it here, group number. So we're gonna be group number 1. Okay. I'll put that here, group 0, right? For now, group 0 and 0. And Darius, Mandy, are you there?
Morning. You could assign me to any group.
Okay, you don't know anybody. Okay, so I'm gonna put you with Matthew, okay? Matthew, group number 1, okay?
Okay.
You two are in the same group. It's gonna be like 4 students per group. It's a relatively large class, so you can do that. Next is Edito Bonilla. Are you there, Edito? Yeah, I don't see Molly. Darius. Edito here, sorry. Edito, no. Next is going to be Naila. Buen rostro. Naila, I don't see Naila either. Jazzy Castellano. Okay, I'll put it with group one. Do you know anybody in the classroom first before I assign you to a group? Do you know anybody in the classroom that you would like to be in your group, Jazzy? Okay, with any group. Okay, so I'm gonna put you with group number one. So start contacting Matthew, right? And Darius. You can do that through Canvas, right? Canvas has everybody's name there in the email. Okay, and let's go for Gabrielle. Gabrielle
I am here.
Contreras. Okay.
I'm here.
Okay, so do you know anybody in the class that you'd like to be in the group with, Gabrielle? Gabrielle?
No, I don't know anybody.
No? Okay, so I'll put you in group number one, okay? So make sure you get hold of the other students. Matthew, Darius, Jazzy, and you, Gabrielle, okay? Next is Liliana Cortez.
I'm here.
Okay, thank you, Liliana. Do you know anybody in the classroom that you'd like to be in your group?
No.
No? Okay, so you're going to be group number two, okay? And as we go along, I will add the students to your group, okay? Juan Salvador Escalera. I don't see Juan here. Yeah. Oh, yeah, he's here. One is here. Okay, good. Do you know anybody in the classroom that you'd like to be in your group, Juan? Any groups fine? Okay, so join the group with Liliana. Okay. Start exchanging emails, send messages to each other. Group is fine. Let's see, Molly Fitzgerald.
I'm here.
Okay. Okay, do you know anybody in the classroom that you'd like to be in your group?
I do not.
You do not? Okay, so I'll assign you to group number two, okay? So here you go, Liliana, Juan, and Molly. Next is Josh. Stephen, okay. Josh, let's see if this Josh is here. Josh Gonzalez, are you there, Josh? No, doesn't look like he's there. Okay, I'll put group zero here for now. Henry Kim. Are you there, Henry? I see Henry right in here. Looks like Henry is away from his computer. I'm gonna put a star under his attendance. And next
Oh,
is
Professor, I'm here.
oh,
Sorry.
okay. Henry,
And
right?
yeah, Henry, yeah. And I don't know anyone, so you could just randomly put me in any group.
Okay, so why don't you join the group with Liliana, Juan,
Oh, sorry.
and Molly? Okay,
Okay, thank you.
Liliana, Juan, and Molly. Next is going to be Ruth.
Here, Professor.
Okay, do you know anybody in the classroom that you'd like to be in your group?
No, I don't know anybody. You could put me in with Henry and
Okay, so you're gonna
Molly.
be group number 3 for now. Okay, let's see, Noemi. Okay, here you can assign me in my group. Okay, good. So I'm gonna assign you with the group with Ruth. Okay, Noemi. So, Danae.
I'm here, and I don't know any.
You don't know anybody, right? Okay, so I'm assigning you for group to group 3. Okay. Ruth, Noemi, and Danae. Danae. Okay, Danae Miller. Next is Ramon Olivares.
I'm here.
Okay. Do you know anybody in the classroom, Ramon?
No.
No? Okay, so why don't you join group number 3 with the other 3 students? Next is going to be Taylor.
I'm here, and I don't know anyone, so you could assign me.
Okay, you're going to be group number 4. Alexis Quijada. I don't see Alexis here. Nope. Alexis is not here, right? Okay, so 0. Next is Stephanie Ramos. Stephanie Ramos. Ramon, I don't see.
Oh, I'm here, but I don't know
Oh,
no one in the class either.
okay, so I'll put you with Taylor. Okay. Go. Your group number 4 was Taylor. Okay, next is Jeremiah. Hello, Jeremiah, are you there? Okay, Jeremiah is not answering. Maybe it's away from the computer. When raise and group 0 for now. Sean Rosario. Oh, Jeremiah. Okay. Oh, let's go back to Jeremiah. Don't know anyone. Okay, so I'm gonna put you with group number 4. Okay, Jeremiah. Okay, so next is Sean. Hello, Sean.
Hello.
Okay.
I don't know anyone.
You don't know anyone? Okay, so why don't you join group number 4? Taylor, Alexis, and Stephanie. Group 4 is complete. Let's see, Evelyn now. Are you there, Evelyn? Evelyn Rizovale. I don't see Evelyn here. Ali, Dominique, Standard. I don't see Ali either. Next is Jason Straight.
I'm here and I don't know anybody.
Okay, so let's see, you're gonna be on group number 5, okay? And watch out for the names of those students who joined group 5. Elena Trujillo.
I'm here. You can assign me with anyone.
Okay, so why don't you join the group? The group is Jason. Okay, Jason Jason Straight. And next is Jason Valadares. See, I don't see Jason Valadares here. Yep. Next is Stephen Vadhapali.
I'm here. I don't know anybody in this class.
Okay, so here you go. So I'm gonna put you in group number 5 with Jason and Elena. Okay. Let's go for Larell now, Larell Williams. Let's see, I don't see Larell here in my roster. Jason Valadares, let's see. Oh, wait a minute. I skipped Jason, right? Okay, good. So do you know anybody in the classroom, Jason? No? Okay, so I'll assign you to group number 5. 1, 2, 3, 4. Next now is Larell Williams. Doesn't look like Larell is here, right? Okay. Nuhamin, Wandimu. See. Nuhamin. No, I don't see Nuhamin here. Alia Zavala.
I'm here and I don't know anyone.
Anybody? Okay, so here you go. And 1, 2, 3, 4. Okay. Let's see. Let's put group number 6. Okay, Brianna Carrillo.
I'm here and no, I don't know anybody in the class.
Okay, so join the group with Alia. Okay, and let's see, Matthew Ritchie. Are you there, Matthew? I don't see Matt. Oh, yeah, no, that's not the one. Agiri Mata. Let's see, Agiri Mata. No, it's not one. Okay, so for now, I have only 2 students in your group. Okay, Brianna and Aliyah. Let's wait another week before I close your group, okay? And I hope most likely we'll be able to add some more students to your group. And if I can't, then I'll see what I do, okay? Now let's 22, yes, 22, good. 9:42. Let's see, Audrey Aguilar, are you there, Audrey? Audrey and Aguilar. Okay, Audrey is not answering me. Okay, so what I'm gonna do now, I'm going to I'm going to create a Google folder, a group folder in my Google Drive. Okay, we have assigned lab groups, most students. Now I will give you the link of your group folder, which you will use throughout the whole semester to upload your lab reports. Okay? And 9:44. Let's go here. Let's see, Google Drive. Google Drive. Let's see my drives here. 2024, spring, summer. So new folder. New fall. New folder. Group number 1. Group number 2. Group number 3. Group number 4. Group number 5. We have a total of 6 groups. Yeah, 6 groups. Group number 5. Next. Group number 6. Okay, 9:46. Let's take our break. I want to take a little break right now. So before I give you the links of your group folder, we will take a break, okay? 9:46 to 10:01 a.m. 10:01 a.m. Okay? Break. Okay, so let's have our break now, and then in 15 minutes we return here with the links for your group folder. Stop sharing. Yeah, I forgot to record this session, so we lost more or less like 45 minutes, unfortunately. But now we have it. Okay, so we go, and let's say that this object, this red dot, is moving from one place to another. Okay, at time t equal to 0, it is at position 5 meters. And at time t equal to tf sub f has this final position, and let's say the final instant of time is 4 seconds, right? So here we have two different positions, the initial position and the final position, the primary definitions, right? And here we have one of the basic quantities, time. One is at time t equal to 0, the other at time t equal to 4 seconds. Okay? So the first thing that I'm going to illustrate for you is going to be the next, my next definition. We have the primary definition, and then we also have the secondary definition, okay? And the secondary definition, I'm gonna call displacement. Remember that, okay? It's very important. The displacement is the final position minus initial position, xf minus x naught. We usually, we like to simplify. We usually like to simplify our notation. So everything that has a final subscript, f subscript, which denote to final, we remove it. Okay? So we can put this way here. Right in here. Okay? To simplify the notation, it's very important that we simplify our notation without losing important pieces of information. Okay? And that's what I did here. I didn't lose any important pieces of information because there is only one parameter that is denoted by the x, by the letter x. Okay? And what else do we have here? Okay, in the case of this specific example that you saw, the displacement that we have there in this example is x naught equal to 5. Okay, so here you go. I put this is another example. Okay, x naught is equal to 5 meters, right? And x final is equal to 3 meters. So we end up getting an example minus 2 meters. The displacement in this specific case is 2 meters, minus 2 meters. And because we have a minus sign, the arrow is pointing to the left, okay? And this arrow, by the way, is represents a quantity that we call a vector, okay? Let's see here. Okay, here you go. That's the example that I'm doing here in my. Okay, so in addition to the concept of displacement, in addition to the concept of displacement, we also have the concept of distance traveled, which I denoted by the letter D. Okay? Distance traveled. Whatever is shown in your odometer, in the odometer of your car, is not the position, it's not nor the displacement, nor the displacement, but the distance traveled since by your car, since it came out from the factory, right? Okay. The distance traveled, D, is always positive. Distance traveled, D is always positive, okay? And is given by the formula. Okay, here you go. XF, X minus X naught. But it's going to be the modulus of X, okay? Which is, in this case, 2 meters. Okay, do you see the difference? Important difference. Important difference between distance traveled and displacement. Okay. And that's what you have writing here in this, in this slide. Okay, here you go. Distance traveled is the magnitude in the one-dimensional, for one-dimensional motion, is the magnitude of the final position minus the initial position, plus 2 meters. Okay. Here is another example of displacement. So let's say, suppose that the particle now decides to go back to its original position. Okay, here we have the delta x1, right? Delta x1 that was minus 2 meters. And here, you know, the particle decides to go to its initial position. And from 3 to 5, the displacement of the particle is going to be plus 2 meters. Let me emphasize that. Plus 2 meters. And the displacement is going to be, the distance traveled is also going to be 2 meters. But suppose that I come to you and ask, look, what about the displacement from with respect to this initial position here, right? The particle traveled from the right to the left and then went back to this initial position. Okay? So the new displacement now is going to be final position 5 meters minus initial position, which is 0 meters. Okay. But what about the distance traveled? Okay. The distance traveled is going to be 2 meters to the left plus 2 meters to the right. Okay. And it's going to be 4 meters. So that's an important difference between this distance traveled and displacement. One can be 0 meters, the other can be something else. In addition, right, to have a displacement that's always positive, you may also have different numeric values for the distance traveled. Okay, so here you go.
Professor, can you go
Yeah.
back to the slide you were just on?
Okay, you want the drawing?
Yes, please.
Yeah, this one here.
So distance is on the right and then displacement is on the left for the formulas.
Distance is, yeah, this one is distance traveled. Yeah, that's right. And this one here is displacement. That's right.
Thank you.
In the left is displacement, in the right is distance traveled. Yep. Okay. So we make these definitions, okay? Your in the case of your car, the car never displays what is the position of the car, never displays what the odometer of your car, right? Never displays the displacement of your car. It displays only the distance traveled by the car. Okay? Whether it's one-dimensional motion, whether it's two-dimensional motion, whether it's three-dimensional motion. Because your car can also do three-dimensional motion, right? If it's going up a hill and doing some turns, it's going to be moving in the three-dimensional space. Okay, and here you go. What else can we talk about here? Okay, D equal to 4 meters relate to what? The odometer of your car register. All right. Go. Here is okay, here we're going back to the first displacement, -2 to the left. And now we're going to talk about a new quantity. Okay, so we have, I'm going to repeat that. Here we go. We have the primary definition. We have the secondary definition, that's a displacement. And now we're going to talk about this tertiary definition, which is the average velocity. Okay. Average velocity. Here you go. The average velocity is defined as being displacement over amount of time, delta x over delta t. Okay? So delta x, and delta t, this is delta x and this is delta t, right? Initial time is usually given as being equal to 0. Okay? In this example here, that the object is moving to the left, delta x is in this case is going to be -2 meters. And if it took it 4 seconds to move to the left, the average velocity of this object is going to be 0.5 meters per second. Okay? Remember also what I told you before, right? You cannot have I told you last time, right? You can never have sum and subtraction between quantities that have different units, right? That's not correct to subtract T naught from XF. Not allowed. And you cannot sum either, because they have different units. However, you can multiply and divide quantities of different units. And the average velocity is just one example of that. I am dividing something that has the meter as its main unit, divided by something else that we call seconds. That we call the time, right? Amount of time that is given in seconds. Okay, and look here at the notation that I'm using, okay? Average quantities are usually represented by this bar at the top. But some books also denote average quantity by a subscript AVG. Some books, but this one is a more widely used notation. Okay. So one example for average velocity is this one that you see right here. If a particle moves from the right to the left, minus 2 meters in 4 seconds, it will have an average velocity of half meter per second. Okay, here you go. By the same token, we have distance traveled. For the displacement, right? They're related to, in a way, they're related to each other. We also have a similar quantity for the average velocity. Remember, velocity, I'm calling that velocity. Okay. Okay, remember, there is displacement, there is one. Displacement, position, right? 2, displacement. There is distance traveled. And then there is also average velocity. And there is this other quantity that we call average speed, okay? Average speed. That's usually denoted by the little letter V. Average speed is going to be given by, here you go, V equal to distance traveled, D divided by T. Okay? Average speed. Okay, and by the same token, that the odometer of your car displays the distance traveled, the speedometer, not velocimeter, the speedometer of your car displays the speed, display its speed. Okay? So let's go to some examples, right? Examples. In this case here, okay? Moving from X naught to XF, velocity is XF, see PowerPoint. Velocity is minus half meter per second, right? But moving from X naught to XF, the speed is plus half meters per second. Well, yeah, I have a problem uploading the PowerPoint. Okay, I cannot do that, but you can take a look at the recordings that is going to display the PowerPoint there. Okay, Molly, it's very difficult to upload the PowerPoint. It's going to be very heavy. It's going to be very difficult to consult it. I did that before, and it's really difficult. But I recommend that you follow the recording. Okay? And so we go. Now, what about the next one? Let's see. Let's take a look at another example, right? This one here, x naught to x1, x1 to xf, right? What about the another example? Example one. Example one. Example two. X naught to x1 and x1 to xf. See PowerPoint. X naught, X naught. Ah. I hate that. I never figured out how to eliminate this thing. Hopefully you folks know how to do that. Let's see. Okay. Now XF. Okay. XF. 11:04. We are about to get into our break here. Okay, moving from x0 to x1 and to x1 to xf. You know, displacement is 0. Displacement is 0. And velocity is also 0. But moving from x0 to xf, let's see. And velocity, but moving. Okay. A, displacement is 0 and velocity is also 0. But distance traveled is 4 meters, right? And speed is, what's the speed? Let's see, 4 meters, right? 2 to the left, 2 to the right. And we are talking about 6 seconds. And the speed is going to be is 4 meters divided by 6 seconds. 6 seconds, or 2/3 meters per second. So do you see the difference now in between? Do you see the difference? So that's the difference. So that is the difference between displacement, which by the way, is a vector quantity, and distance traveled, which is a scalar quantity. Scalar quantity. Okay. And we can say the same about the basic quantities and the primary definition. Okay? We got primary definitions, they are vectors. Vectors. And the basic quantities, they are scalar. Scalar quantities. Okay, 11:07. Let's take a little break now. It's another break from 11:07 a.m. to 11:22 a.m. Okay, any questions? So I see you in 15 minutes. See you soon. Okay, I'm back here, and I saw, here you go. Molly, all right, came up with a question here. So when we resume class, can you explain the different times on the Cartesian coordinate system and what numbers you take for the velocity equation? Okay, so here you go. Let's go here. This one, right? You're talking about this one, right, Molly? This is slide here.
You're not sharing your screen, Professor.
Oh, sorry. Thank you. Thank you for letting me know. Here you go. That's the one you're referring to, right?
Yes.
Okay, so notice that it went from this position to this one and then went back to the initial position, right? So let me get your question again here. Okay. What numbers you take for the velocity equation, right? Okay, the displacement is 0 meters, right? Do you agree with that? No problem, right? It went back to its initial position, so consequently the displacement is 0, right?
Yes, that makes sense.
Okay, because the displacement is 0, when you do delta x over delta t, the velocity is going to be 0 too, right? The average velocity is going to be 0 as well, okay? But the same cannot be said about the speed, right? And the distance traveled. The distance traveled is what? 2 meters plus 2 meters, right? 4 meters here. And delta t is going to be 6 minus 0, right? So it would be 4 divided by 6 meters per second, which is 2/3, 0.666. Okay? Do you see the difference now between velocity and speed?
Yes, thank you.
Okay. So you may have a displacement being equal to 0, but the distance traveled will not be necessarily equal to 0. Okay. The concept of distance traveled, is more difficult to calculate than the displacement. Okay. If we are talking about one-dimensional motion, distance travel is no big deal. It's not a big deal. It's because the particle is moving only along the single axis. But then when we start looking at two-dimensional motion, for instance, then calculating the distance travel becomes more difficult. Okay? Why is that? Because the particle now is free to move all over the place in a two-dimensional space, right? Particle can go this way, and so on. And then you have to sum all those little, short lengths to get the displacement. Okay? So I'm going to write that down here in the notes. This one here. Okay. The concept of distance traveled is more difficult. Distance traveled, let's put it this way. Distance traveled is more in the one-dimensional space, in the one-dimensional space, distance travel is not difficult at all. It's not difficult at all to calculate. Okay? However, when we are dealing with a two-dimensional space, it may become extremely difficult to calculate the distance traveled, especially if the infinitesimal displacements are sections of a curve, okay? Sections of a curve. So, right? Caution, right? Caution. In the one-dimensional space, distance travel is not difficult to calculate at all. Not at all. However, when we're dealing with two-dimensional space, it may become extremely difficult to calculate the distance traveled, especially if the infinitesimal displacements are sections of a curve. Okay? And we need 3. Okay, so and now that we have talked about, let's throughout this course, okay, throughout this course, we will concentrate on the concepts of displacement and average and velocity. There will be very few problems on distance traveled and speed exactly because of this difficulty in calculating them in the 2D space. Okay, Henry Kim is getting hit. 11:30. So now we are going to concentrate on position, displacement, and average velocity. And now there is something else that you have to know that's called the instantaneous velocity. Okay? So the instantaneous velocity is a concept in physics as well. It's the value of the average velocity taken whenever delta t is very small or close to 0. So notice that as delta t becomes very small, so that's delta x. So that's delta x. It's like dividing a very small number by another small number, by another very small number. The result's not going to be necessarily 0 or infinite. Instead, it may be a finite number. Okay? So here we have an example of two functions. One being divided by the other, close to the value x equal to 0. Okay? Okay, sine of x over sine over x, it's a very good example whenever x is equal to 0. Okay? Remember, sine of 0 here is going to be 0, right? And x at x equal to 0, we also have 0 downstairs. But we do know that this ratio that you see right in here, and we represent it by this, by this notation here. I'm going to put it between parentheses as well. limit of as x goes to 0 of sine of x over x is not going to be, an indefinite number. It's going to be a finite number. And I can prove that to you if we go into Excel, okay? So the importance for you to get familiar with Excel. Let's do that. Okay, so here we go. Maybe I can do that. No, let's go. Okay, I'm going to do the following. I'm going to put sine of x here. Even better, I'm going to put x as well. Okay? And I'm going to start with number 10. 9.9 and so on, okay? Okay, 9.9, 9.8, 9.7. And I will, have you ever thought about that? Have you ever seen something like that before? Freeze paint, yeah, I can do that freeze paint. There will be a total of 100 data points here in my table. Oops. And what am I doing here? I am making my numbers going to 0. Point 3, point 2, point 1, 0. Yeah, it's almost 0. 10 to minus 13. I'm going to put 0 here. Okay? And remember, because it is and now what I'm going to do here, I'm going to take the sine of x, right? I'm going to calculate that. And let's see what's going to happen. Then I'm going to divide one by the other. And let's see what happens. Let's see if it is a fortunate example too, right? Let's see. Yeah, this is not a fortunate example. Let's do a different one. We're going to start with 1 here. Okay. And then we're going to start 0.9. Okay. That would be a better example. Let's see. Hopefully that will be a better example. Let's set and let's see. Yeah. And now I'm already calculating the sine of x here. I choose the number x and I calculate sine of x as well. Okay. And now what are we going to do here? We're going to divide sine of x by x. Okay. Sine of x divided by x. And don't forget, I'm doing that so x goes to 0, right? It's moving towards 0. And see what happens. First, we start at 0.84, right? 0.84, 0.85, goes up to 0.86. Okay, that's the type of thing that you can see only by working with a software like that of Excel, okay? 0.88, started with 0.84, and now you're already at 0.88, okay? Is this sine of x divided by x here? Let's keep on doing that ratio. And I want to calculate sine of x over x whenever x goes to 0, moves towards 0. See, we started with 0.84 and we're already at 0.92. As we get closer and closer, as the x get closer and closer to 0, this number will get closer and closer to what? Hopefully you already know the final answer to that.
0.
Huh? 0? You said 0? Try to do that with your Excel. Huh?
1?
1.
Yeah, that's right. It's 1. Okay. See, 0.99, 0.991. Okay, here you go. It
Professor,
goes
I have
up.
a question.
Yeah,
When you input on the very first column,
yeah.
when you put that sine of x and then sine of x divided by x,
Uh-huh.
is that just a computation that the computer does by itself, or did you set something beforehand?
Well, I gave values for x, right? That you understand, right? Right? Okay.
Yeah.
And then I want to know what sine of x divided by x is all about, right? As you go towards 0. What do? I calculate sine of x for all those values of x as we move closer and closer to 0. Okay?
Yeah,
And
but
then
I mean, do you have to, is there like a coding thing that you have to do? Or do we
no,
just type in?
it's a very simple coding. It's a very simple coding. Okay, so look what I did here. See that? Sine of A2, right? See that? Sine of A2, right? The code is very straightforward, right? I just type sine, right? Open parentheses, and I click A2, right? And then what do I do next? I divide one by the other, right? The blue by the red. Okay?
Yeah.
Make sense?
Yeah.
And then you can see that it gets very close to 0. Here, it doesn't calculate because Excel doesn't know how to divide 0 by 0. Okay? But Excel knows how to divide those small numbers that are not 0. Okay? And you can see that this number is very close to 1. Okay? This number is very close to 1.
He's asking how did you get the first column to autofill the numbers?
The first column is that autofill, right? It does autofill. What did I do in the first column? I typed 1, I typed 0.99, right? And because I'm lazy, right? I don't want to keep on typing 0.98. I don't want to keep on typing 0.97, right? So Excel has this feature that's very useful. Just by typing 1 and 0.99, Excel automatically, keep on filling the next the next cells with a 0.01 value. Okay, let me erase that for you here. You're gonna see it. I'm gonna let's see, clear contents, right? Okay, so here you go. Let's say I typed 1 and 0.99, and I don't want to type the rest because it would be too much work, right? So Excel has this nice feature that allows you to go one by one. See that? 0.98, 0.97, 0.96, see that? If the difference is the same, Excel will do that. And the same thing would happen if I want to write down 1, 2, 3, 4, 5. Right? Here you go. See that? Excel has this nice feature that cut down on the amount of work. Does it answer your question?
It does. Thank you. I wasn't phrasing it right. Thank you.
Yeah. So that's one way of finding out the ratio of those two quantities, right? Another way of finding out the ratio of those two quantities is just by remembering that the limit of sine of x, right, as x goes to 0 is approximately, don't forget this is a very important approximation that we learn in math. Let's see, is approximately right here, approximately equal to x. Okay, that's why you end up having a number 1. Okay, this finite number here would be 1, and I proved that using Excel. Okay, I proved that using Excel. So that's what the instantaneous velocity is all about. We're dividing something small by something else that is also small. Okay? And the concept of instantaneous velocity, there you go, in a formula-wise way, it's like limit of delta t goes to 0, delta x goes to 0. And it will be also a finite number. Just like we have a finite number here in this case in these ratios here. Name as the answer. Let's see. I need to see the format of the cell. So also doesn't do it automatically. Really? Okay. Huh, strange. What's the value of cell B2? Let's see, cell B2. Lots of questions, right? Let's see, let's manage to answer everything here. Let's see, how do we access Excel through Canvas again? I do not know how to access Excel through Canvas, okay, Sean? But you can access through the, not through Canvas, but I know that you can access through your email, okay? If you go to your email, you're going to find a link to Excel and other programs as well. Highlighting the first row. Okay, so lots of questions here. Let's see if I can answer everyone, right? Let's see, 12, sorry, okay, let's see. What did you do after highlighting the first row, right? Okay, I clicked and drag, okay? That's what I did after highlighting the first row, right? And I click it and drag. Here you go. Well, I'm going to do that again. I'm going to do that again, right? 1 and 0.99. See here, this little, there's a little square here at the edge, lower right edge, right? So if I click and drag, it's going to display 0.98, 0.97, 0.96, right? Okay. Can you see that? Can you do that in your Excel too, Jeremiah? Okay, so let's see. It just inputs all the values as one. Yeah, sometimes Excel does that. You know, I think it's a bug in Excel. Sometimes it does that to me as well. You just input all values as one, right? Sometimes it does that to me as well. But make sure that you highlight those two values, okay? I do not know why Excel does that, you know, but you're right. Sometimes I have the same problem, okay? Sometimes I have the same problem and I do not know why. I think it's because it's a little bug in Excel. I do, and it changes from 0.99 to, yeah. Yeah, that's right. Sometimes something like that happens. You know, you just keep on repeating 1.99, 1.99, right? Yeah, sometimes something like that. But this time here it's not doing that, right? And I just don't know why Excel does that. You know, I just do not know. But maybe if you come back later on in Excel, this is going to do exactly what it is doing right here for me right now. Okay. I don't have, let's see, let's go to the next one here. 11:36, 11:12, 11:22. How did you highlight? Okay. How do we access Excel through Canvas again? Again, I don't think that we have access of Excel through Canvas. I think that we have access to Excel only from your email. Okay? Okay, Sean? I'm not sure that if you can access Excel through Canvas. Download Excel and sign up using school email. Yeah, okay, that's Ramon's answer. Okay, Aliyah Zavala 1. How did you input the value of X? Yeah, so I did that here, right? If you cannot, if it's not working the way it's working here for me, just you have to input, 0.98, 0.97, just everything manually. Okay, it's a lot of work, but that's what it is, right? What's the value of cell B2? This value of cell B2 is the sign of X, right? Sign of X. Sign, and you'll see that I have this cell value here is highlighted, right? Here you go, I'm gonna do that again. Sign, okay? Sign, and then you click on this value here. It automatically displays the position of the cell, A2, okay? And then you click and drag, right? You click and drag, it does that automatically. See that? It starts with A2, next is A3, A4, A5, and so on. Okay. What's the value of cell B2? B2 is a sine of 1. Sine of 1. Don't forget, the sine of 1 is 1 radian. It's not 1 degree, okay? Everything that goes inside the function sine, cosine, tangent, and so on is given in terms of radians, not in terms of degrees. Okay. It's not letting me do that. Did you manage to, Sean, did you manage to do that, or is still not doing the way it, I'll get back to you. Okay, mine also doesn't do it automatically. Yeah, mine gives me the name as the answer. I need to see the format of the cell. Yeah, you gotta show me why it's giving you the name in there. I do not know either. Here, do you see? Let's see. Here. Okay. See, I have here a very small number, right? But if I put 0, exactly 0, it does a division by 0, right? Mine gives the name as the answer. I need to see the format. It works for me, but highlighting both numbers. That's right. You have to highlight both numbers. Look for the black plus sign to show the little black. In my case, it's not black, is it? Let's see. In my case here is green. See the little square at the lower right of this square, right? You click and you drag. You don't have a little square? Well, what a shame. Yeah, you gotta share that with me. Okay. Are you using a PC or are you using a Mac? Let's see. 745. What's the formula for column C? Okay, is one divided by another. What's the formula for column C? Is this one here divided by this other one, okay? I was able to get to filling the numbers by going to the data table and clicking data tools and choosing flash fill. Okay. Wow, that's a long way, right? Okay. Yeah, Jeremiah, got it. That's the formula for sine. Thank you, drag the formulas. I do it and changes to 1. Yeah. I don't have the little square. Yep. Yeah, that's like in my case, I do have the little square here. Maybe you can see it. Oh, yeah. See the little square right here. Yeah, check, check carefully, see if you have the little square or not. Okay. Okay, so let's move forward. We have 10 more minutes to go. And, okay, so here you go. That's the definition of instantaneous velocity. The next idea, the next concept in physics, okay? And we are not going to do this type of calculation here in this course because this is required, okay? We are not going to do this type. We will not do this type of calculation in this course since it requires calculus. But at least you are introduced to this concept. Okay. Okay, so when I did drag, I got, let's see. Really? Let's see. Let's see. Let me do Contreras, like Gabriel Contreras. Let's see what's going on there. You said x 0.01, right? 0.01. And then sine. Okay. So see, Gabriel, I'm getting 0.01, okay? I'm not getting 0.298272 like you said, right? I'm getting 0.01. I can even increase the number of decimal places here. Format cell. Yeah, Okay, so you can see that's not exactly 0.01, but it's very close to it. Okay, so there might be a problem there on your Excel, right? Or maybe you didn't type correctly. Okay, check. Okay, so I have x 0.01, right? Sine of x is this one here, and then sine of x over x is almost 0.1. It's almost 1, almost the unit. Okay. Did you fix that, Gabriel? Or you're still getting the same values? Well, I'm not hearing answer from Gabriel. I'm still not getting the same, but strange, strange. Maybe if you stay around, I will. You can share the screen with me, and then I will find out, figure out why you are getting this result. If you want to stay after the class is over for office hours, we can figure out what's going on there. Okay. Well, let's see, 11:54. I think this is a good point to stop. Okay, and let us stop now. And if you want to, if you want to stay around for my office hours, I'll be here. Okay, I will be here. So, any questions? So I see you next Monday. Okay.
Thank you.
Welcome.
Thank you.
Welcome.
Have a good one, Professor.
You too.
Thank you. Bye bye.
Thank you. Bye bye. Let's see more. Okay, you have a good weekend for you all, right?
I have a question, Professor.
Yeah. What's that?
Do we have any assignments due this weekend? Like, how do we know what we have due?
Let's see. Let's take a
Just to
look
make
at.
sure.
We do have assignments. We do have homework assignments. Do you see the deadline for the homework assignment? Let's take the only assignment that comes to my mind is the homework, but it's still down. Maybe a few weeks from now. Let's take a look here. Homework, October 2nd. See that? Homework 1 and homework 2 are due on October 2nd. Okay.
But it's all the homework based on like up until now to next month? Like online? I just want to
Yeah,
make
all the
sure
homework is online. All the homework is online.
Okay.
And it covers the material that I cover in class, right?
Okay.
Okay. Gabriel.
Okay, thank you, Professor.
Okay. And Gabriel, go and share the screen with me to see what's going on there in your computer. See
Bye,
here.
Professor. Have a good one.
Okay, so let me see. Let me I gotta do some changes here. Stop sharing and the sharing. Okay, now, yeah, here you go. Now you can have access. Okay, so let's go up. Let's see there from the okay. One, okay, 0.84, is that what I got, right? Let's see, yeah, 0.84. That's good. 0.84. Okay, keep on going down. It looks like you're getting the right value. See that? It's going as you get closer and closer to 0, it is approaching 1, right? Oh my, but wait a minute, let's see, 0.13. Now let's see. 0.13, 0.36. Okay. Let me see. 0.19. Click on 0.19. Oh, wait a minute. No, click on 0.19. The number. Yeah, here you go. Now click next to it. Yeah, see, you do not have a formula there. Something happened there that I do not know what happened. You have to type sine of x there. Equal sine of x. Equal sine. Oh, it's not sine of x. Open parenthesis, sine of 8143. Yeah, click 0.19. Click 0.19 and it will. Uh-oh. No, you gotta open the parenthesis, right? Sine, open parenthesis. No. Erase the. You gotta, okay. Click in the cell next to it. Yeah, here you go. Now you do sine. Oh, that's good. Open parenthesis. I don't see the open parenthesis. Oh, yeah. Okay, good. Now you click the cell next to it. 0.19. Good. Close parenthesis. Close parenthesis. Now return. Okay? And now you have to click and drag all the way up and down. Okay, because something happened there in your spreadsheet. I do not know what happened in your spreadsheet because it stopped. Yeah, you don't have to drag all the way down that. Yes, here you go. Okay, see? And click and drag upwards as well. No, you gotta click, okay? Yeah, here you go. Click and drag upwards. The little square, yeah, here you go. Good. Yeah, okay. We'll keep on going up. Yeah. Okay, now click there. Yeah, for some reason you have just the numbers there. You don't have the formula. Strange. Now let's look at the yeah. See in this third column, you don't have the formula. You just have the numbers. I do not know why. So equal. No, don't write sign. Equal. Erase the sign. Yeah. Now click the cell to the left of that. Divided. Now the other cell. 0.19. Good. Return. Now click and drag down and click and drag upwards. Yeah, see that? Very close to 1. Now you gotta click and drag upwards as well. Yep. Oops, overshoot. Good. Okay. Do you understand what happened there? Now you
Yes,
have
thank
everything
you.
right, huh?
Okay. Thank you so much.
Oh, well, you're welcome. So for some reason, I do not know why you had the numbers there instead of having the formulas. Okay. For some reason. But
I
now
just did the
everything,
quick. Okay. I get it now.
yeah, everything is straightened out.
Thank you.
Welcome.
Bye, Professor. Have a good
Bye-bye.
day.
Ah, wow.